Here is 101 amazing facts about the Voyager 1 spacecraft, which happens to be the farthest man-made object ever. Voyager 1 is currently the farthest human-made object from Earth, having crossed into interstellar space in 2012. What's bizarre is that it's still communicating with us across more than 15 billion miles, sending back faint signals that take over 22 hours to reach Earth, requiring some of the most sensitive antennas ever built to catch its whisper from the void. Despite its incredible distance, Voyager 1 still uses 8-track tape memory systems to store data before transmission. This primitive memory system, with just 68 kilobytes of storage, is utterly dwarfed by even a basic digital photo today, yet it has successfully carried out a mission spanning nearly 5 decades. Voyager 1 isn't even aimed at the closest star. Instead, its current trajectory means it won't come near another star system for over 40,000 years, and when it does, it'll still be too far to see any significant planetary features, just drifting silently into a vast and uncharted darkness. In 2022, NASA engineers were baffled when Voyager 1 started sending back nonsensical data. It wasn't corrupted by radiation or damaged hardware, but likely due to an unknown failure in its attitude articulation and control system, a 45-year-old machine having a software glitch we couldn't physically fix. Voyager 1 carries a golden record that includes music, greetings, and sounds from Earth. What's unsettling is the fact that this record may one day be found by alien life, and their interpretation or misinterpretation of our culture could shape humanity's unknown legacy across the stars. Voyager 1 is powered by plutonium-238, a radioactive element slowly decaying within its RTG, radioisotope thermoelectric generator. As its power source fades, scientists must selectively shut down instruments, essentially deciding which parts of this historic probe will die first in order to keep others alive. One of the eeriest facts about Voyager 1 is that it has entered a region of space where the sun no longer dominates the cosmic environment. It's now in a part of the galaxy filled with galactic radiation and cosmic rays that our solar bubble used to shield it from, space without sunlight. Voyager 1's journey was helped by a 176 years planetary alignment that allowed it to slingshot around multiple planets using gravity assists. If it had missed this window, we would have had to wait another century and a half to try the same mission again. Even after traveling for over 47 years, Voyager 1 hasn't left the solar system entirely. It's crossed the heliopause, the boundary of the sun's influence, but it's still considered to be within the sun's gravitational grip. That means the sun is still faintly tugging on it, light years away. Voyager 1 once took a picture of Earth from 3.7 billion miles away, known as the pale blue dot. In that tiny speck of light, every human being who has ever lived existed. The haunting photograph was so powerful that it led Carl Sagan to reflect on the fragility and unity of life on Earth. Voyager 1 continues to run on technology that predates personal computers. It doesn't have a modern operating system, no real-time software updates, and yet it navigates deep space, avoids errors, and relays back scientific data using the same logic it was built with in the 1970s. In deep space, Voyager 1 travels at a speed of about 38,000 miles per hour. Even at that velocity, it will take over 70,000 years to travel just 1 light year, proving how terrifyingly vast and isolating the universe truly is beyond our solar neighborhood. The spacecraft uses a 23-watt transmitter to send data to Earth, about the same power as a refrigerator light bulb. And yet, this whisper of a signal can be detected by the Deep Space Network's massive dishes, which are among the largest and most powerful antennas on Earth. Voyager may first end up drifting alone in the galaxy longer than Earth itself exists. If humanity vanishes or is wiped out in the next few thousand years, Voyager 1 could remain as the only physical trace of our species, silent, dark, and endlessly moving into the abyss. The plutonium powering Voyager 1 generates heat that's converted to electricity, but the efficiency is so low that most of the heat is wasted. Despite this, the little heat that remains keeps the spacecraft's critical instruments from freezing solid in the near absolute zero temperatures of space. Voyager 1 has not been upgraded or repaired in any way since launch. It relies entirely on redundant systems, self-correcting protocols, and blind commands from Earth. It is the longest operating spacecraft in history, aging through space while Earth-based engineers struggle to keep up with its needs. The spacecraft once experienced a roll that caused its antenna to slightly misalign with Earth. That slight deviation reduced its communication capability drastically, highlighting how even the tiniest miscalculation or natural drift in deep space could sever our last thread of contact with it. Voyager 1's instruments were not designed to function in interstellar space. Every piece of data it sent back from this unknown environment is an unexpected bonus, collected by aging sensors long past their intended lifespan, providing the only first-hand glimpse humanity has ever had of this region. Voyager 1's golden record includes the sound of a kiss, a heartbeat, and a mother's greeting to her newborn. These sounds, embedded in a spacecraft flying through interstellar emptiness, are the most human things in the least human place imaginable. Though the spacecraft is traveling away from us at over 10 miles per second, the signals it sends back are so weak by the time they reach Earth that they register at a fraction of a billionth of a watt, making them harder to detect than a digital watch on the moon. Voyager 1 doesn't have a camera anymore because its imaging system was shut down in 1990 to save power. Since then, it has been flying blind, continuing its mission without being able to see where it's going, like a ghost ship navigating by memory alone. While Voyager 1 is in interstellar space, it's not in a perfect vacuum. It regularly encounters tiny particles of dust and interstellar gas, which can collide with it at high speeds. Even a microscopic grain traveling at thousands of miles per hour could cause damage. The golden record aboard Voyager 1 includes greetings in 55 different languages, some of which are already considered endangered or extinct. This means the spacecraft may one day preserve voices and languages of people and cultures that no longer exist on Earth. One haunting aspect of Voyager 1 is that it's so far away now that if something catastrophic happened, like its antenna failing or instruments freezing, we might not find out for days, and there would be nothing we could do about it but watch the signal fade to silence. Voyager 1's radio signals grow fainter every year, not just because of distance but due to declining power. Eventually, it won't have enough energy to transmit anything at all. It will fall silent in the 2030s, becoming a dark relic wandering the cosmos. Among the music on the golden record is a 3,000-year-old Chinese song, Flowing Streams. It's chilling to think that this ancient human composition is now traveling through a region of space where no human sound has ever existed, an echo lost in infinite silence. If an advanced alien species were to find Voyager 1, the instructions engraved on the golden record include a diagram on how to play it. However, those instructions assume a knowledge of physics and math similar to ours, an assumption that could completely fail if alien logic differs. Voyager 1 isn't going to crash into anything anytime soon. In fact, despite the billions of stars in the Milky Way, the distances between them are so vast that the spacecraft is unlikely to encounter another object for trillions of years, making its path the ultimate form of isolation. The gold-plated copper disk on Voyager 1 is designed to last over 1 billion years in space. Even if everything else about humanity is destroyed by war, climate collapse, or extinction, this one disk might be the longest-lasting monument to our existence. Although it's often praised as a triumph of science, Voyager 1 was built on a shoestring budget for a government agency that had never sent anything so far. Many of its parts were reused from previous missions, making its success a testament to ingenuity under constraint. Voyager 1's computers are less powerful than a modern digital watch. It uses a system from the 1970s called a command and data subsystem, which can only process one instruction at a time. Despite this, it has flawlessly executed complex maneuvers and experiments over decades. The data Voyager 1 returns is often garbled by cosmic radiation. Earth-based scientists must decode these jumbled messages using decades-old engineering documents, many of which exist only in paper archives or as faded blueprints stored in NASA warehouses. Voyager 1 isn't just flying straight out into space, it's being slowly pulled off course by the gravity of distant stars and galactic forces. Its final trajectory will be the cumulative result of subtle tugs from objects, it may never come close to seeing. Though often romanticized, Voyager 1's trip is also a slow death. It loses power every year, systems are being shut down one by one, and eventually all communications will cease. The spacecraft will still move forward, but as a corpse adrift in the dark. Voyager 1 carries a stylus and cartridge to play the golden record, assuming it's found by intelligent life. But the instructions are etched in human units of time and measurement, assuming aliens understand hydrogen frequencies and Earth's anatomical proportions, an assumption based on hope, not certainty. The spacecraft has experienced occasional bit-flipping events due to cosmic rays, where a 1 in its memory can become a 0 or vice versa. This can result in strange behaviors or incorrect data, forcing engineers to spend weeks decoding and correcting simple memory errors. Voyager 1 flew by Jupiter in 1979 and captured the first clear images of its moon Io, revealing active volcanoes. This shocking discovery reshaped our understanding of moons, showing they weren't just dead rocks, but could be geologically alive and dynamic. There is a real chance Voyager 1 might outlive Earth itself. If a global extinction event, nuclear catastrophe, or astronomical impact wipes out our planet, Voyager 1 would continue silently drifting, unaware that the civilization that launched it no longer exists. Every command sent to Voyager 1 today must be precisely coded, translated into 1970s computer language, and transmitted with perfect accuracy, because the spacecraft has no capability for real-time communication or software correction. Each signal is like writing a note to a ghost from across the stars. As it moves through interstellar space, Voyager 1 is providing the first direct measurements of the galactic environment. We had no idea what was really out there, how dense the plasma was, how strong the magnetic fields might be, until Voyager began sampling and sending back these groundbreaking data. Voyager 1 is flying through a region of space where light from our sun has faded into obscurity. The sun, once a brilliant star dominating the sky, now appears as just another distant among billions, stripped of its warmth and meaning. NASA once lost contact with Voyager 1 in 2023 due to a corrupted command that rewired its telemetry system. For months, scientists received only gibberish. The spacecraft had no idea anything was wrong, blindly obeying faulty instructions until engineers found a fix using 45-year-old documentation. It took engineers more than a decade to fully understand and utilize all the capabilities built into Voyager 1. Many of its systems were designed with hidden features or redundancies that were only discovered or activated years after launch, often in moments of desperation. If Voyager 1 ever enters a dense interstellar cloud, it could be bombarded by charged particles and magnetic fields far more intense than anything in our solar system. Its instruments weren't built for this, meaning it could be fried without warning, becoming an instant space relic. Voyager 1 is traveling into a region of space with no known destination. It's a permanent exile from the solar system, and unlike every other mission we've launched, it has no chance of return. Its path is final, absolute, and endless. It's possible Voyager 1 might someday fall into a black hole. With enough time, perhaps trillions of years, galactic drift could carry it close to a stellar remnant that consumes it completely. All its data, record, and materials would vanish in an instant, never to be recovered. Voyager 1 has entered a plasma-rich environment in interstellar space where the density of particles is far greater than expected. This new data challenges our fundamental understanding of how stars and solar systems interact with a wider galaxy and has rewritten cosmic boundary maps. The magnetic field Voyager 1 has detected beyond the heliopause doesn't seem to align with solar or galactic models. It's oriented in strange, unexpected directions, raising questions about whether we fully understand the forces shaping the space between stars. One of the eeriest facts is that Voyager 1 will eventually die in complete darkness. As its RTG fades, heaters will fail, instruments will freeze, and systems will stop working. Its final state will be cold, silent, powerless, spacecraft entombed in its own shadow. Voyager 1's journey reveals how alone we truly are. After leaving the sun's influence, there's been no detection of intelligent life, no signs of alien civilization, nothing but radiation and silence. In a universe of hundreds of billions of galaxies, we seem horrifyingly alone. NASA scientists still rely on ancient documentation, handwritten notes, dusty schematics, even old employee memories to understand and maintain Voyager 1. Some engineers have had to reverse engineer 1970s technology just to keep the spacecraft functioning, like archaeologists decoding a digital relic. The deep space antennas on Earth that listen to Voyager 1 must constantly compensate for the Earth's rotation, axial tilt, and seasonal position to keep locked on its location. Even a brief misalignment could mean the end of communication forever. Voyager 1 helped discover the complex radiation belts around Jupiter and Saturn, warning future missions of their lethality. Without this knowledge, the Galileo and Cassini missions could have been fried by radiation, potentially ending in failure. Voyager 1 was our cosmic scout. Despite its staggering distance, Voyager 1 still receives signals that are incredibly faint, equivalent to a billionth of a watt. To detect them, engineers use giant radio dishes over 70 meters wide and advanced signal processing that can filter noise from nearly nothing. Though Voyager 1 carries data meant to represent all of Earth, it includes no mention of religion, politics, or war. Carl Sagan and the team felt these topics might misrepresent humanity or provoke misunderstanding if discovered by alien civilizations with different moral frameworks. The Golden Record features 27 musical tracks, including Bach, Beethoven, Blind Willie Johnson, and a Peruvian wedding song. This mix was curated to reflect both cultural diversity and human emotion, yet no one knows how an alien species might interpret rhythm, harmony, or sound. Voyager 1's power is declining by about 4 watts per year. By the mid-2030s, it will no longer be able to power any instruments or its communication system. At that point, it will still be speeding through space, but totally blind, mute, and alone. The spacecraft's protective shielding is so thin that it's constantly bathed in deadly cosmic rays. Humans aboard would be killed in hours. Yet somehow, Voyager 1's electronics have survived nearly 5 decades in this invisible, relentless bombardment. Voyager 1 is traveling roughly toward the Ophiuchus constellation, but it will never reach it. The stars and constellations shift over time, and by the time Voyager gets remotely close, tens of thousands of years from now, those stars will have moved elsewhere in the galaxy. Voyager 1 confirmed that space is not empty. It's filled with plasma, interstellar particles, and magnetic fields. This medium affects how stars evolve, how galaxies form, and how light travels, proving that the so-called void between stars is more complex than anyone imagined. Voyager 1 has revealed that the boundary of our solar system isn't a hard edge, but a turbulent, shifting region where solar winds collide with interstellar plasma. The transition wasn't clean. It was violent, noisy, and filled with unexpected turbulence that lasted over a year. Although it is now in interstellar space, Voyager 1 is still gravitationally bound to the Milky Way galaxy. It's expected to orbit our galaxy's core once every 225 million years, completing a galactic circuit, long after Earth's continents have rearranged or disappeared. Voyager 1's data has revealed that even in deep space, low-frequency sound waves ripple through interstellar plasma. These eerie space quakes occur far beyond the sun's reach, creating ghostly vibrations that are detected not by microphones, but by instruments that sense changes in electron density. When the spacecraft captured images of Saturn's moon Titan, its dense atmosphere blocked surface features from view. However, these murky photos were among the first to confirm a nitrogen-rich atmosphere, similar to early Earth's, fueling speculation about Titan's potential for harboring exotic life. Voyager 1 flew past Jupiter's Great Red Spot and captured time-lapse footage of the storm's swirling fury. This storm has been raging for centuries, and the spacecraft's footage showed how it moved like a living organism, spiraling, pulsing, and devouring smaller storms in its path. The spacecraft carries a pulsar map, a cosmic address pointing to Earth's location based on the timing of 14 known pulsars. It's a brilliant piece of astrophysical navigation, but it also exposes our position to anyone who finds Voyager, friendly or otherwise. In a grim twist of irony, if a malevolent alien race were to find Voyager 1 and decode the golden record, they would know where we are, what we look like, and how we sound, possibly making us the galaxy's most naively exposed species. Because of the spacecraft's limited memory, when it was active, it would often overwrite its own data before it could transmit it back to Earth. Each measurement had to be prioritized, and many priceless observations were simply deleted to make room for more. Voyager 1 doesn't use GPS, radar, or star trackers. It navigates using celestial mechanics and simple onboard gyroscopes that track its attitude relative to distant stars. It's an ancient form of cosmic orientation, using the sky itself as a compass, utterly dependent on its memory of stars. One of the strangest things discovered by Voyager 1 is that the edge of the heliosphere, the bubble created by the sun's solar wind, is not symmetrical. It's warped and compressed on one side, likely due to the pressure of an unseen interstellar magnetic field. Voyager 1 was never meant to last this long. Its original mission was designed for just 5 years to explore Jupiter and Saturn. Everything beyond that, interstellar travel, 47 years of operation, and its record-breaking distance, is essentially an accidental miracle of engineering. The spacecraft's main communication system uses a high-gain antenna shaped like a giant dish, which must stay perfectly pointed toward Earth. If this antenna ever shifts by more than a fraction of a degree, we would permanently lose contact with the probe. Voyager 1 is now so far from Earth that it can no longer accurately resolve the positions of stars in the sky as we see them. Its view of the universe is now distorted by distance, relativity, and the curvature of galactic space. The spacecraft passed through a region known as the Magnetic Highway, where solar magnetic field lines connected with interstellar ones. It was a brief window of communication between the Sun and the galaxy, an invisible corridor never seen before or since. Voyager 1 discovered that Jupiter emits powerful bursts of radio waves. These emissions, now known as decametric radio emissions, come from interactions between the planet's magnetic field and its moon Io. They're some of the loudest natural signals in the solar system. If Voyager 1 ever reaches another star system, it will be traveling so fast that it wouldn't be able to slow down or orbit the star. It would shoot right through at tens of thousands of miles per hour, just a flash in an alien sky. Even today, Voyager 1 receives instructions at a rate of just a few bits per second. This is slower than the speed of early dial-up internet. Sending a high-resolution image today, if it still had cameras, would take days to transmit to Earth. The spacecraft's subsystems are slowly failing. Engineers have shut down non-essential heaters, exposing components to deep space temperatures near absolute zero. Some instruments continue to function far below their designed temperature thresholds, operating in conditions no one believed they could survive. Voyager 1 revealed that Saturn's rings are not solid structures, but composed of countless tiny ice particles. Its images showed spokes and gaps in the rings that shift and change, behaving more like liquid or plasma than anything static or predictable. It is possible that Voyager 1 will eventually collide with a rogue planet, asteroid, or interstellar debris. But the chances are incredibly low, so low in fact that it could drift untouched for trillions of years, long after stars have burned out and galaxies have dissolved. Voyager 1 will likely continue drifting long after all stars in the universe have gone dark. As the cosmos ages and stars burn out, the probe may still exist in a lightless void, a dead machine drifting eternally through a universe that has gone cold. In 2020, engineers rerouted commands through Voyager 1's backup thrusters, in use since 1980, because its primary attitude control system was wearing down. Miraculously, they still worked after 37 years of dormancy, demonstrating the spacecraft's incredible resilience and redundant design against astronomical odds. The spacecraft's thermal blankets had degraded so much that parts of Voyager 1 are colder than expected. These sub-zero temperatures risk freezing fuel lines or electronic solid, yet somehow the craft remains operational, a testament to 1970s engineering outlasting its expected lifetime by decades. Voyager 1 has outlived many of the scientists who helped build and launch it. New generations of engineers have had to inherit the project by deciphering decades-old documentation, sometimes with handwritten margin notes being the only explanation for certain decisions or system designs. Although it's far beyond any known planet, Voyager 1 continues to be influenced by gravity from the Sun, the galaxy, and even dark matter. These cumulative forces will shape its path forever, subtly steering it through space, even in the absence of any propulsion. One terrifying implication of Voyager 1's mission is how easily it could vanish. A micrometeoroid impact, cosmic radiation surge, or final system glitch could sever all contact instantly. We'd never know what happened, just an eternal silence from the oldest traveler we ever launched. Voyager 1 carries a map showing Earth's location relative to 14 pulsars, assuming their timing remains constant. But pulsars can shift or decay over thousands of years, making the map potentially obsolete or misleading by the time any alien civilization finds it. The spacecraft's golden record features 116 images encoded in analog format. However, if the finders don't decode the signals correctly, the images could appear distorted, producing terrifying, unrecognizable visions of Earth's people, animals, and landscapes, a surreal hallucination of what we meant to portray. Voyager 1 helped identify lightning on Jupiter by capturing its radio emissions and light flashes. This marked the first confirmed extraterrestrial electrical storms, proving that planets can harbor violent weather systems similar to Earth's, potentially even more powerful and destructive in alien atmospheres. Despite not having any AI or advanced software, Voyager 1 can autonomously execute recovery routines if it encounters errors. These built-in systems act like a primitive immune system, allowing the spacecraft to heal from glitches that could otherwise end its mission. NASA calculates Voyager 1's distance using a method called Doppler tracking, measuring frequency changes in its faint signal. But this method becomes less precise the farther it travels, meaning at some point we may not know exactly where it is, just a ghost moving somewhere unknown. Voyager 1 revealed that the edge of the Sun's influence, known as the heliopause, is not smooth but foamy and jagged. It's more like a turbulent shoreline than a boundary, filled with eddies, shocks, and unseen plasma structures colliding with interstellar matter. After decades in space, Voyager 1 still uses 3 onboard computers: the CTC, the FDS, and the CCS. These processors operate with less memory than a modern calculator, and no hard drives. All data must be encoded in real time, transmitted before being lost. When it passed Saturn, Voyager 1 discovered that the planet's magnetic field is nearly perfectly aligned with its axis of rotation, an unexpected and puzzling phenomenon that defies what we know about magnetic fields. Scientists still don't fully understand how this is physically possible. Though it is alone, Voyager 1 isn't silent. It constantly emits weak radio waves that ripple outward like whispers in the cosmic dark. If an alien civilization had similar receivers, they could theoretically detect our signal, like eavesdropping on a lonely voice from another world. Voyager 1 flies through space at such incredible speed that it covers the distance from Earth to the Moon in under a day. But in the vast emptiness of interstellar space, that speed is still agonizingly slow, insufficient even to reach another star in 70,000 years. The spacecraft was launched before the internet existed, before personal computers were common, and before cell phones. Yet it continues to function in a world utterly alien to the one it left behind, an artifact from a past age still participating in cutting-edge science. Voyager 1 detected ultraviolet emissions in Jupiter's atmosphere, helping scientists understand the auroras there, 10 times more powerful than Earth's. These ghostly glows, driven by the planet's intense magnetic field, revealed violent and unexpected energy interactions in the outer solar system. Even in deep space, Voyager 1 experiences pressure, just not from matter. Radiation pressure from starlight and cosmic rays exerts a constant, if minuscule, force on the spacecraft, like the wind pushing a sail. Over millions of years, this can nudge its course ever so slightly. If intelligent life ever finds Voyager 1, it's unclear whether they'd even understand what they've discovered. The Golden Record assumes basic universals, math, sound, time, but those are all filtered through human perception. What if the universe doesn't share those fundamentals? Voyager may remain forever undeciphered.